All right, so y'all, this is a question from 7.2. This is number 12. And the problem here says a company makes cola drinks, excuse me, states that the mean caffeine content per 12-ounce bottle of cola is 50 milligrams. Okay, so the first thing I'm going to do is I'm going to say the mean caffeine content is 50 milligrams. We'll make this pen a little bit thinner. There we go. Okay, so the claim is that mu is equal to 50 milligrams, right? Excuse me, this is my claim. And so the opposite of saying something is equal to is saying that something is not equal to 50 milligrams, right? So the first one is going to be our null hypothesis because it has the equal to part. And then the second one is going to be our alternate, right? So now what I'm going to do is I'm going to see if I can figure out of my choices A, B, C, D, E, and F, which is the one that is the null, the HO, and which is my alternate, the HA. Okay, so before even reading the entire problem, I'm going to do that because that's what it's asking me to do in this first part right here. So we want the HO to be equal to 50 and the HA to not be equal to 50. And it looks like that's going to be choice F. So I'm going to come back to my problem right here, and I'm going to choose F. There we go, and we're going to check our answer. And okay, we got that part right. Come on, pen. There we go. Okay, so now it's asking us to find our critical values. Okay, so let's see if we can do that part. I'm going to take a screen of this, and come back to my slides over here. And I'm going to upload this picture. There we go. Okay, so now we're trying to find our critical values. So the first thing I notice, y'all, is that since our claim, there we go, is the null, the null, which is saying that HO is equal to 50, and our Ha is saying that mu is not equal to 50. Oh man, what's wrong with this pen? Let's see. Remember, my HA, y'all, tells me whether or not this is a left tail, right tail, or two-tail test. Since it's not equal to 50, this is going to be what we call a two-tail test, right? So we're going to have we're going to have our critical values. We're going to see if we can figure out how we're going to find this, right? So look what it's telling me. It's telling me that alpha here is 0.08. So what I want to do over here, y'all, I just took a screenshot of this for the notes, for my notes. So it says, how do we find our critical values in a normal distribution? So we're going to find our level significance alpha, which we knew in this case was 0.08. Since we are looking at a two-tailed test, the z-score that corresponds to half of alpha and 1 minus half of alpha. Okay, so what's half of alpha? Half of alpha would be 0.0, not 0.5 Omar, but 0.04. There we go. Okay, so the area here, y'all, and I'll actually do this part in red because I think that's typically what I do. Go like this and go like this. So the area here is 0.04, and the area there is going to be 0.04, okay? So if we're trying to find these critical values, remember this one here is going to be negative, and this one here is going to be positive. The way we can find that part, y'all, we can go with the inverse norm of 0.04. Okay, so let me take my calculator. Here we go. Let's clear everything out. So we're going to go second and vars. We're going to go to the inverse norm, which is number 3, 0.04. And I'm coming up with a negative 1.75. When I come back to my slide, okay, I know that this critical value here is negative 1.75. Sorry about my stylus here, y'all. It's kind of on its last legs, I think. And this one is a positive 1.75. So the two critical values we're going to have are going to be plus or minus 1.75. So I'm going to come back to my problem. Here we go. And right here, 1.75. If you notice, there's already the little plus and minus in front of it. And all right, we got that part. Okay, so now, where are our rejection regions? So I'm going to come back to my slide again so you can see what I'm looking at. So if I look at this picture here, let me see, I thought I had it in my notes, but maybe not. It's okay. Let's take a look. So this here, I'm going to do this part in green, y'all. This is my fail to reject region, and then these are my rejection regions. So anytime I'm to the left of negative 1.75 or anytime I'm to the right of 1.75, that's going to be my rejection region. So let's see if we can do that on my lab. And so I'm going to come back over here. And so this is what we're looking at. We're looking at something like this because, again, you can see where we're going to fail to reject and we're going to reject. And, okay, we got that part done. Hold on, y'all. I'm going to get a different stylus. Hopefully this one works a little bit better. There we go. Okay, now we want to find our standardized test statistic. So let's see how we're going to do that, okay? Let me take a screenshot of this. And I'll upload it my slide over here. There we go. Excellent. Okay, so let's find our standardized test statistics. So again, y'all, I'm just using my notes here. And this is what we are looking at right here. Oop, wrong one. There you go, 7.2. This is the one we want. So let me take a screenshot of this so we can find our standardized test statistic. Look, let's come back over here and let's upload this part right here. Okay, this right here, y'all, is how I'm going to find my standardized test statistic. So the formula is z equals x bar minus mu divided by sigma over the square root of n. So let's see if we can do that for our particular problem. Let's see. Let me pull up the problem here. Here we go. We want to find our standardized test statistic. Okay, so we know that our mu is 50. Let's see. We have a sample of 30. So n is 30. 12-ounce bottle of cola. And the mean content, so my x bar is 51.3. And assume the population is normally distributed and the population standard deviation is 7.6. So my sigma is 7.6. Okay, so now that I have those pieces of info, y'all, I can come back and I can use this formula. So look, we're going to go z equals, what was our x bar? 51.3. So I'm going to put this in parentheses, minus my mu, which we knew was 50, and then divided by sigma, which was 7.6, divided by the square root of n, and n in this case was 30. So we'll go like this. Okay, I'm going to enter this piece, y'all, in my calculator exactly as I see it, okay? So let me grab my calculator real quick. Parentheses 51.3 minus 50 divided by 7 point, what was it, 7 point something? 7.6. 7.6 divided by the square root of n, which in our case was 30. I'm going to close out those parentheses. I'm going to hit enter, and I'm coming up with 9.36. So I believe it's usually asking me to round to 2 decimal places. I'd say 9.4. So my z value is going to be, or 0.94, because we are going to 2 decimal places. So let's go ahead and check our answer. So right here, we're going to enter in 0.94, enter that in, and okay, we're doing great so far. Okay, so now we have to decide, are we going to reject or fail to reject the null hypothesis? So what I'm going to do here, y'all, I'm going to come back to my slide. Where were we? Here we go. Okay, so remember, I'm going to clean some of this mess up because I know it was a little messy and my pen wasn't working too well. So the numbers that we had here was a negative 1.75 and this was a positive 1.75. And those were my critical values, right? We just did our test statistic and we came up with a point 90 something, 94, 96, something like that. What was it, 94? Okay, so we came up with a point 94. So look what region we fell into. We fell in the fail to reject region, right? Okay, so now what I'm going to do is I'm going to come back to my original problem. And we're going to say since z is in the is not in the rejection region, we're going to fail to reject the null hypothesis, right? We fell somewhere in the middle. We're going to check our answer. Okay. All right. So now we have to decide what is it we're going to do. Okay. So this is the part, y'all, where I use that little cheat sheet that I had. So let me show you how I'm going to do this. I'm going to come back to my slide, and I believe it was, maybe I haven't uploaded it yet, so I'll upload it now. Okay, so let me choose, and here we go. This is what I'm looking for. Okay, so remember, our claim happened to be the null hypothesis. And if you're wondering, how did I know that? When we came back, when we were first starting off, and I'll even come back to our very first slide. Here we go. Remember, the claim was the null part, right? That was the HO. So we knew that our claim was a null. So I'm going to come back, I'm going to look at my slide again. Okay, claim was a null, and we fell in the fail to rejection region. So we're going to say there is not enough evidence to reject the claim. So I'm going to come back to my problem here, and we're going to say there is not enough evidence to reject the claim that the mean content per coffee of cola is equal to, what was it in this case, 50 milligrams? And we're going to check our answer, and we got it, okay? So again, it's a process in doing these problems, y'all. I don't want to lie that it's, super fast. It's not. But I'm hoping that as I'm doing these problems here and I'm kind of going through each of the steps, it makes sense on how I'm able to do this, okay? If y'all got any questions, let me know. I'm happy to help.